Never send a man to do a machine's job.
What are we actually building today? Welcome to Engineering the Hard Problems, a series of technical podcasts by Epsilon. In this series, we look at some of the hardest engineering problems at scale and how Epsilon is imagining it and how they are solving it. My name is Vaibhav. I'm a principal site reliability engineer here at Epsilon infrastructure team. Today's session specifically focuses on one such problem. How do you scale infrastructure without creating any chaos, bottlenecks, and burnouts to engineers? I have with me Sudharshan, who's VP of IT Operations, who's actually leading an initiative to scale infrastructure into a product-led organization. Sudharshan, welcome.
Thanks, Vaibhav. Happy to be here. This particular topic is very interesting to me, given that what we are trying to do is at the intersection of platform engineering, reliability, and solving operations problem through automation.
Sudharshan, what is the core problem we are trying to solve? What is broken today with the traditional infrastructure model?
Most of the organization, the way they treat infrastructure is like a service, and there is nothing wrong with the model.
Yeah.
But if you want to deliver a consistent experience to your end users, you need to think beyond a service model. Now, what do I mean by that is, just imagine AWS console. AWS has built this entire experience. Either you come through their console to provision an infrastructure, operate it, or you come through the APIs or a CLI, or even SDKs.
Yeah.
So each time you interact with this infrastructure, your experience is consistent. And also it empowers rather than being a tightly coupled model which infrastructure team operates. For example, let's say a user opens a ticket. Engineers logs into the machine, fixes a thing, they document everything, then they close the ticket. Now, this is okay when you are operating at a ticket level of like say 200, 300. But if you are an organization that gets 10,000 or 20,000 tickets, this model becomes a bottleneck, it collapses. Now we are trying to solve this problem exactly by building platform capabilities and make those platform capabilities into a product, offer that to the end user wherein they can get the consistent experience every time they interact with the infrastructure.
Very interesting. What makes this problem hard at scale? What is the real challenge? When you start scale and when you see it at this scale with what we have at Epsilon infrastructure particularly today.
As you know, as every organization grows, infrastructure grows, and you get new business units onboarding their new applications or databases or workloads. Now, when that happens, you are naturally creating more infrastructure provisioning with the existing capabilities that you have. It could be some scripts that you go provision an infrastructure with, or it could be some script that somebody has written, you go run that, remediate an issue. But that can't scale as your infrastructure or the environments grow. That is where you need to have a very holistic idea or a thought process. How do I solve this problem at scale? So the scale becomes a bottleneck, and you need to have mechanisms to solve that exact problem. Another way is, you cannot just add more people linearly in a team and expect them to support ever-growing infrastructure. The third thing is, never send a man to do a machine's job. If you think from that perspective, then your natural choices becomes only quite a few, right? Either you build those capabilities so that you can operate your infrastructure at scale. So that is a major problem in the existing infrastructure. And also another problem is, a lot of people, let's say there is an opportunity for automation, they just start jumping into writing one. Without thinking that automation can become much more than just a autonomous script. How do I build a platform capability of some script that I think can outlive its actual usage? If you start thinking in that direction, then you are naturally evolving automation thought process into a platform initiative. Then that platform you can take it to the next level, create a product out of it. So these are some of the hard problems that exist in every organization around infrastructure.
I've seen this as well at scale. When you start scaling, platform teams become a bottleneck, and the more we shift this into a self-service sort of a model, right? I think that is when we can really not become a bottleneck, and this scales well across the organization. Interesting. And another thought is, what are we actually building today? And you spoke about your thoughts on how we can scale this. What are we actually building?
Yeah. Now, if you look at not only Epsilon, but a lot of other organizations around the industry, many companies have solved this problem by building self-service capability. It is not a new solution, but the way you build the solution has to be sustainable, scalable, and successful, more importantly. In many organizations, there is always a central team, a platform engineering team.
Yes.
They build a service portal. They stitch all the backend code stack to it, and then they expose that to the end user to use. Now, that can scale again to only to an extent. Imagine you have so many teams coming and asking you the new feature requests, or they're pointing you towards bugs in some of the systems you built. Then you as a central team become a bottleneck altogether.
Yes.
You are sitting on huge backlog of things.
Absolutely. Yep.
Customer requests, feature requests, and then some bugs, and then you have your own roadmap. How does this platform should evolve? So then you are creating a bottleneck if you have this model. Now what we are trying to do is we are trying to build a very open source kind of a model on the principle of open source model. That's the reason all these open source CNCF projects are so popular, right? How are we doing it? When we got this infrastructure as a product idea. Now let me explain for a second, what is that infrastructure as a product, right? I talked about AWS console as an example. If you can enter through infrastructure world through UI, user interface, or through an API, or through a SDK, or even through a CLI, and get the things you want to done, like say I want to provision a Kubernetes cluster, I want to provision a EC2 instance, or I want to patch a machine. When you can abstract all the complexity of these actions with a simple way a user can consume on their own, then you are eliminating the human in loop altogether.
Yes.
And then the solution can scale for any of the number of environments you end up building. Okay. Now, having said that, when you are not only building this yourself, but also empowering the other teams, the end users, hey, this is how you build a software template within Backstage, or this is how you create an end-to-end workflow. Then they also feel empowered. They also add back to your platform capabilities. That way your platform becomes more robust than your one team becoming a bottleneck.
Makes sense. I think you mentioned about several things, Backstage, N8N. Very curious to understand what the architecture looks like.
Yeah. So as I told, we are trying to build a product kind of an experience for infrastructure. Now, always like all the products have a entry point, which is a user interface. We are also building a user interface using Backstage. Now, what is Backstage? Backstage is an open source internal developer portal that company like Spotify developed for their own use case initially. It became so popular they open sourced it. Most of the organizations who have a self-service capabilities, they usually choose Backstage for building it. The reason is it's open source and also it has ready-made plugins you can integrate into many backend systems. Let's say if you don't have a integration, writing one integration is also straightforward and you can contribute that plugin back to the community. We have written one integration in Ansible which did not exist in Backstage. Okay, now Backstage is your entry point or the front door of this platform or a product. Now on the back end, we have a huge technology ecosystem, right from ServiceNow, which is our ticketing system, to Jira, where we do all the software development. And then we have our Bitbucket, the code repository. And then, of course, we have multi-cloud, AWS, GCP, and then we have our huge data centers through which we provision the infrastructure, right? We use Ansible for infrastructure provisioning as well as configuration management. So, N8N is kind of sitting in the middle of this, where it is doing all the orchestration capability. Naturally, Backstage doesn't have a very strong orchestration engine. That's the reason we chose N8N. It's not just an orchestration engine. Beyond that, we are using N8N for many other things, which I'll talk in some time. So this is how the very high-level architectures look.
Yeah.
And we are trying to build a very loosely coupled model.
Got it.
So that if you want to add any new integration, it should be a very straightforward.
Yeah.
How do I integrate some new stack with N8N or with Backstage? So we are thinking in this direction. This is how the architecture looks like today, Vaibhav.
Got it. Got it. One common question that probably comes is solutioning is one thing, but what about governance, guardrails? Things can go wrong because they have lots of engineers working on using all these tools, and unless we have good governance and guardrails in place, how are you thinking about some of the failure patterns that can surface, and how are you thinking about solving some of that?
I think this is one of the favorite question among even senior leadership,
Yeah.
right? When we are thinking of building anything new,
Yeah.
company like Epsilon, which has a huge customer base, and also we process data like payments data,
Yeah.
we always have to put security first. And in my opinion, security is non-negotiable for various reasons. Now, having said that, when we started thinking about this product initiative using Backstage and N8N, we of course had to run all these ideas
Yeah.
through security and get their blessings. They gave us a lot of good feedback, good questions that we had to revisit and then think the entire architecture from the security angle as well. And then we started building these capabilities, right? For example, most of the companies, what happens is automation is just a script or bunch of scripts. We are trying to treat every components that we are building like a software artifacts. And we are going to host these artifacts through a very rigorous SDLC process.
Yeah.
For example, if somebody is writing an N8N workflow, you can directly go write it in N8N.
Yep.
But if many people are writing workflows and reverting the version, somebody goes and changes something, it can create chaos and problems. We are trying to avoid that. So we are trying to build SDLC capabilities, governance framework around how we build these capabilities and have a very clear path to production. How do I write a workflow? How do I test it thoroughly? Then how do I promote it into production? So some of these initiatives and controls is what we are trying to plug into the entire development lifecycle as of now.
You mentioned about N8N. That caught my attention because N8N is a low-code development solution. I think any team would love to use something low-code because it not only accelerates development efforts. How are you actually leveraging N8N in this architecture?
Yeah. So when we looked at the problem is very simple. It is M number of tools, N number of people interacting with those tools to get anything done. A typical permutation, combination, problem statement.
Yeah.
Now there are a lot of tools in the market that can solve this problem. Within Epsilon, we use a bunch of different tools as well, like UiPath is there, bunch of other things are there as well. Now why N8N? Again, I'm a big fan of open source products that I want to use. It comes at no cost, and also there is good amount of learning, and the community is also great there, right? So N8N was a natural choice. The second reason is the learning curve with N8N is so simple.
Yes. Yes.
It has beautiful DAG diagrams,
Yeah.
and the backend is all JSON, key value pair, the configuration. If somebody wants to write a workflow, all that you need to do is write simple steps, then translate that into different nodes within N8N, then create a workflow. So it's your run book basically becoming a beautiful diagram, right? And when we picked it, it had a little bit of a learning curve, but the entire team picked it so well. Now today we have around 80 plus workflows. That's all in rigorous testing. And using this orchestration, basically this particular platform N8N does what a human does. Logging into a system, checking something, taking that output, going updating a service now ticket, and then sending a notification. Imagine if some engineer is supposed to do all this. It just takes some amount of time. I think that time is better spent in creating workflows rather than doing it again and again. Of course, a couple of times they have to do it manually till they understand the complexity of this workflow. Once it is written down, created to a runbook, then convert that to workflow. Then your workflow becomes your artifacts. And then you build platform capability using those artifacts. Then you create a product out of it. This is exactly what we are doing with N8N as a backend. Okay. So right now N8N is literally touching every technology stack what we have within infrastructure space, so that I have a capability getting anything done from that other stack. Okay.
So, Sudarshan, we are in this phase of evolution where things are evolving in infrastructure. What is the role of infrastructure, a lot of teams within infrastructure today, and how would every engineer's role change with all this evolution?
Yeah, it's a good question. Like if you look at infrastructure engineers' role 15 years before, we all started with the iron age of data centers. Now came the cloud evolution and the virtualization. Then came site reliability engineering. Now we are in the era of platform engineering and developer experience. The future era is definitely going to be the AI-driven infrastructure. Right now, having said that, infrastructure engineers should focus on building platform capabilities than just doing anything manually, and even just writing one of a script, because that shelf life is going to be so limited, it will be useless probably in a couple of months down the line.
Yeah.
So I think engineers should focus on building platforms in a decentralized manner that is so robust that those platforms will outlive the same people who are writing these automation. That's the whole thought process, right? I mean, that's one of the reason why do you think Linux is so relevant after 40 years of its creation, right? If we have that thought process, I think then we end up creating a platform that empowers the business to operate more efficiently. Now, if you look at from the business perspective, every business want to break the barriers of bureaucracy, get things done much faster. So having said that, I think the entire project what we are trying to work on is exactly motivated by all these factors. Now, what is in it for an engineer here, right? As I told, we as engineers need to adopt to ever-changing technology landscape. Now we are at the forefront of platform engineering today. As I told, it is going to be the AI-driven platforms and infrastructure in the days to come. And being ready for this opportunity, upskilling, and doing what really matters is going to make every engineer more valuable in the market, and is going to be really game changer for every organization.
Okay, interesting. Thing that comes to my mind right now is all this evolution is happening. Where do you go from here? What lies ahead? Very, very curious to know what lies ahead, because we are on this journey now, and interesting to hear from you where we headed from here.
Yeah. If you look at the entire infrastructure evolution, we are still at the era of operating an infrastructure that is not intelligent.
Okay.
Yeah, we have platform engineering capability, we have automation, we have site reliability engineering, DevOps, everything.
Yeah.
But you still need a human to steer the ship here, right?
Right.
Now, with infrastructure complexities growing, organizations moving faster, you need to build the capability of intelligence into everything you do around infrastructure layer. Now, what does that mean? I mean, we are connecting N8N to the Bedrock, AWS Bedrock, which will talk to multiple LLM, different models for all the complex work that need to happen, right? And also we need to build the capability of mean time to context. Mean time to context is, let's say there is a problem. As a human, by the time you understand, oh, this is exactly the problem, when you are able to connect all those dots, you take some time. And that time varies from person to person, because the context you have, the context I have may be very different. That context building, again, you cannot scale just adding more people to it because of tribal knowledge, various factors, right? We can instrument those into platform capabilities where machines will understand the context much quicker, better. I would not say completely better, but it will get better over the period of time, right? That is when your infrastructure, the way you deploy infrastructure, you create infrastructure, you operate infrastructure, then you improve infrastructure. All of this will be embedded with some level of an intelligence. It's already happening in the industry, right? There are a lot of tools and platforms and products who are building these capabilities. So we are also thinking in the same direction. How do we build AI-powered infrastructure to boost Epsilon's growth? That is what is coming next.
Interesting you mentioned about MTTC, because usually teams think about MTTR and how they want to improve MTTR.
Yeah.
Right? They this is very, very, very vital as well, MTTC, because how quickly can you diagnose a problem, right, before you can solve the problem. Right? Teams generally tend to ignore that as well. So you need the right solutions and tools and ability and the right observability solutions as well, so that you can correlate quickly and be able to detect the problem quick. So very interesting the journey has been, and any final thoughts that you have that you want to share?
Yeah, sure. I just want to close with a few thoughts here. Okay, we are not just trying to build a tool here.
Yeah.
We are trying to build a platform empowered product that will outlive the engineers who are writing it today. That way, the product lives on, and it becomes mature. It becomes a crowdsource or an open source model. I think that is a way you can have a product that's going to be successful on a long run, rather than that has a shelf life of probably a year or two, right? That is how we are thinking. And also we are thinking from how do we help everybody move faster?
Yeah.
That's a
Correct.
whole
that's the
motivation behind what we are trying to build. Now, by building these capabilities, we are also empowering every engineer to transform from just a systems engineer to a platform engineer or a AI infrastructure engineering in future. So it's a continuous journey. It's going to take some time, but I think we are getting started. We are 1% complete, 99% work in progress.
Sudharshan, thank you very much for sharing all the valuable insights today. And I think this is something every organization faces, and probably there is something in it for every organization. So this is it for Engineering the Hard Problems from this episode. Thank you very much if you have tuned in to listening to this. And as always, we'll come back with something special in the next episode.